Good evening, students. Welcome back to Wisdom Academy Education. Students, today I will discuss about 11th Chemistry, Chapter 12, Organic Chemistry. Today I will discuss about classification of organic chemistry. Students, in previous lecture, I have discussed about the catenation property and tetracovalency, pi bond, sigma bond, hybridization nature of organic compound. So today I will discuss about classification of organic compounds. Students, all organic compounds are classified on the basis of carbon skeleton, and second is on the basis of functional group. Let's write down, students. You can write organic compounds can be classified on the basis of two ways. Let's data where classify kara jaichi. All organic compounds are classified into two ways. First is based on carbon skeleton, that means carbon presence. Second one is based on functional group. Students, all organic compounds are classified into two ways. The first one is on the basis of carbon skeleton, and the second one is based on functional group. Let's start with on the basis of carbon skeleton. First one will be discussed today. On the basis of carbon skeleton. Students, carbon skeletons, according to carbon skeletons, all organic compounds are classified into two types according to carbon skeleton. All organic compounds are classified into two types, that is aliphatic and is cyclic. Aliphatic, second is cyclic. Aliphatic means, students, aliphatic you can read open chain or aliphatic, and second is cyclic. Next, student, cyclic and aliphatic. Cyclic compounds are also cyclic compounds. Again classified into two: homocyclic and second one is heterocyclic. Homocyclic and heterocyclic. Student, second one is homocyclic is again further divided. Alicyclic, homocyclic is further divided. Alicyclic, student, homocyclic is further divided into alicyclic and aromatic. Aromatics. Students, at first on the basis of a carbon skeleton or organic compounds are classified into two. First is aliphatic, second is cyclic compound. Further, cyclic compounds classified into two types. First one is homocyclic and second one is heterocyclic. Again, homocyclic are classified into two. First one is alicyclic and second one is aromatics. Again, aromatics are classified into two types. That is benzenoid and the second one is non-benzenoids. Non-benzenoids. Students, on the basis of carbon skeleton, all organic compounds are classified into two. First one is aliphatic, second is cyclic. Further, cyclic compounds are classified into two, that is known as homocyclic, and second one is heterocyclic. Again, homocyclic is classified into two, alicyclic and aromatics. Further, aromatics is classified into two. First one is benzenoid and the second one is non-benzenoid. Let's start with, on the basis of carbon skeleton, organic compound are aliphatic and cyclic. Now starts with aliphatic compounds. Write down aliphatic compounds. Today's lecture, I will give just hints about the such classification, not details. Later, I will give another lecture, the details of this. So, aliphatic compounds. What do you mean by aliphatic compounds? Aliphatic compounds are straight or branch chain compounds. These are straight or branch compounds. Straights or branch compounds. Very important. No closed ring is formed. Very important. That means open chain, no closed chain. No ring is formed, no closed ring is formed. So you can open chain. Open chain may be straight or branched compounds. No closed ring is formed. So, what are the some examples? CH3, that is ethane. So another, this is the straight chain. Another branch, CH3COH, acetaldehyde. These are the aliphatic compounds. These are branch and this one is the straight compound. This one is the branch which is not closed ring is formed. So this is known as aliphatic or open chain compounds. There is no chain is formed. It is a straight compound. So acetaldehyde is a branch compound. Also no closed. Second, cyclic compounds. Aliphatic compounds. Second one is cyclic compounds. Starts with cyclic compounds. Cyclic compounds. What are cyclic compounds? Students, cyclic compounds are closed rings compound. These compounds are closed rings compound. That means that compound is closed. So what are the examples? Closed ring compounds, benzene, you can write benzene is closed or ring form, closed ring form. So this is known as a cyclic compound. Another example, you can name it furan. So this is named as furan. Student, in benzene, look at this point. So same type of carbon is present. All our carbon is present. In some cyclic compounds, other than carbon, other atom may be present like oxygen in furan. So in these cases, cyclic compounds are further classified into two. That is known as, first one is homocyclic compounds, and second one is heterocyclic compounds. Heterocyclic compounds. Student, what do you mean by homo? Homo means same. So the compounds contain same type of carbon, that is known as homo, means rings of this compound contain carbon atoms only. Homocyclic means rings of these compounds contains carbon atoms only. Carbon atoms only. Like homocyclic is like that. Benzene, when in benzene only carbon, in carbon atoms are present. Only carbon. This one is carbon, 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 carbon. So same type of atom is present in this ring compound. So cyclic compound is classified into two types on the basis of same type of carbon, same type of atom are present in the ring compound. Another ring compound other than carbon, maybe other atoms are present like furan, where is carbon, 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 but in this cyclic compound, oxygen is another type of atom is present in this cyclic compound. So cyclic compound is classified into two types, homocyclic and heterocyclic. Student, homo means same. The ring compound which contains same type of atom only, that is known as homocyclic. The cyclic compound that contains same type of, homo means same type of atom. Suppose benzene, all atoms are carbon, same type of carbon is present in this cyclic compound. Benzene is a cyclic compound or closed compound where carbon atom only present. So this is known as homocyclic due to same type of atoms are present. In heterocyclic furan, you can give example rings of this compound. What are heterocyclic compounds? Rings of these cyclic compounds contains other than carbon atom. That means other than carbon atoms, they are different atom may be present in a cyclic compound, that is known as heterocyclic. If here is a carbon is present, so it will be termed as homo. In furan, carbon, 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 here is only oxygen is present. So this ring compound or cyclic compound is not completed by same type of atom like carbon, where oxygen is another type of atom is present, so it cannot be called as homocyclic, it can be called as heterocyclic compounds. Students, got my point? Cyclic compounds are classified into two. First one is homocyclic, second one is heterocyclic. Homocyclic, the cyclic compound or rings of these compounds that contain homo types of atom only. That means only contain carbon atom only. Rings of this cyclic compound that contain other than carbon atoms as well. Carbon atom also present, but other than carbon atoms, other atom may be present in a cyclic compound. So this type of cyclic compound is known as heterocyclic. Students, next. Homocyclic is classified into again two types. Homocyclic is two types. What are they? Alicyclic and aromatics. Alicyclic and aromatics. What are alicyclics? That means the chemical properties of this compound is resemble aliphatic compounds. So these are known as alicyclic. Aromatics, that means the compound have aroma and also delocalized pi electrons. Delocalized pi electron. What do you mean by delocalized pi electron? That means suppose here is a benzene. The structure of benzene is like that. So double bond, where is a sigma and also one pi bond is present. The pi bond are not fixed in this formation. So these are delocalized. That means they are not a fixed point. So this structure can be deducted as this, like that means the pi bonds where pi electrons are not fixed, not localized, they are moved freely. So benzene, this structure will be that. So this is aromatics. Later on, the details of this classification will be taught.